You're using Amazon RDS for your production database. The interface is beautiful. Click a few buttons, get a managed Postgres instance with automated backups, read replicas, and high availability, clean, simple, professional. But what's actually running underneath? What version of Linux is the OS? How is replication configured? Where are the backup files physically stored? What happens during a failover? Which systems make the decision? How long does detection take? What's the actual mechanism? How does AWS prevent other customers' databases from impacting yours? You don't know. The interface doesn't tell you. The documentation gives high-level descriptions, but not implementation details. That information is hidden, deliberately, systematically, by design. This is abstraction hiding, and it's one of the most powerful and controversial aspects of cloud computing. Let's talk about what's being hidden from you, why providers hide it, and what that means when you're trusting hidden systems with critical workloads. Abstraction hiding is the deliberate concealment of implementation details behind simplified interfaces. The provider shows you what you need to interact with the service. Everything else, how it actually works underneath, is hidden from view. This is more than just abstraction layers creating boundaries. It's active concealment. The information exists, but you don't get access to it. The systems are running, but you can't inspect them. The processes are happening, but you can't observe them. Hiding happens at multiple levels. The interface hides complexity. You see launch instance, not the hundreds of operations that actually execute. Documentation hides specifics. You get conceptual explanations, not architectural diagrams of provider infrastructure. APIs hide implementation. You send requests, get responses, but the middle is a black box. The key distinction: abstraction creates layers that separate concerns. Abstraction hiding goes further by actively preventing you from seeing through those layers, even when you want to. It's not just separation, it's opacity, and it's not accidental. Providers invest significant effort in hiding implementation details while exposing only the interfaces they want you to use. Understanding what's being hidden and why helps you evaluate whether you're comfortable with that level of opacity. Let's catalog what cloud providers hide and the reasons behind each type of hiding. Infrastructure implementation details are hidden for security and competitive advantage. You don't know the exact hardware specifications of physical servers, the network topology of data centers, or how multi-tenancy isolation actually works at the hypervisor level. Why? Because exposing that information could reveal vulnerabilities or give competitors insights into how to replicate the platform. Security through obscurity has its critics, but it's a real strategy here. Operational processes are hidden for flexibility and simplification. How does AWS decide when to perform maintenance on your EC2 instance? What's the exact process for detecting and replacing failed hardware? How do they allocate capacity during high-demand periods? Hidden because you don't need to know, and revealing it would create expectations that limit their operational flexibility. Failure mechanisms are partially hidden for confidence and complexity management. When a service degrades, you get high-level status updates, investigating elevated error rates in ES East 1. What you don't get: which specific components failed, how the failure propagated, what percentage of infrastructure is affected, or detailed timelines. Some hiding protects sensitive operational information. Some hiding prevents panic. Cost structures are hidden for pricing power. You know what you pay for services. You don't know the provider's actual costs, what it costs them to run a VM, store a gigabyte, transfer data. This information asymmetry gives providers pricing flexibility. If you knew their costs, you'd negotiate harder. Inter-service dependencies are hidden for abstraction integrity. When you use DynamoDB, you don't see that it depends on dozens of other AWS services internally: storage services, monitoring systems, authentication infrastructure. Hiding these dependencies lets AWS change internal implementation without affecting your interface. It also prevents you from understanding failure correlation. Multiple seemingly unrelated services might share hidden dependencies. Performance characteristics are hidden or generalized. You get 3 nines availability SLAs and latency typically under X milliseconds. Actual performance varies by region, time of day, customer load patterns, and physical proximity to data centers. Exact performance data is hidden to avoid unrealistic expectations and difficult support situations. Resource sharing details are hidden for multi-tenancy abstraction. Your VM is on a physical server with other customers' VMs, but you don't know how many, who they are, what they're doing, or how resource allocation works. This hiding is necessary for the multi-tenant model to work, but it means you can't verify isolation or predict noisy neighbor impacts. Security implementation specifics are hidden for protection. How exactly does encryption work? What key management processes are used? How is authentication validated? You get high-level descriptions, certifications, and compliance reports, but not implementation code, architectural diagrams, or security process details. Some hiding is reasonable. Some makes independent security verification impossible. So why is all this hiding actually valuable, not just problematic? Cognitive load reduction. If you had to understand every implementation detail to use cloud services, adoption would be impossible. Hiding lets you focus on your applications instead of infrastructure complexity. You're freed from needing deep expertise in areas outside your domain, faster development and deployment. You don't spend time understanding internals because you don't need to. You consume services through simple interfaces and build products faster. The hiding accelerates innovation by removing barriers, protection from breaking changes. Because implementation details are hidden, providers can change them without breaking your workloads. They can upgrade hardware, modify internal architectures, optimize processes, all invisible to you as long as the interface remains consistent. Hiding enables evolution. Security through abstraction. You can't accidentally misconfigure what you can't access. You can't expose what you can't see. Hiding reduces your attack surface by eliminating configuration options that could be security risks. The provider handles complex security implementations, and you trust their expertise. Simplified mental models. You think in terms of VMs, storage, databases, not in terms of hypervisors, SAN fabric, replication protocols. Hiding lets you work with concepts at the right level of abstraction for your needs. You're not drowning in details that don't matter to your use case. Abstraction hiding, done well, is protective. It shields you from complexity that would slow you down and create opportunities for mistakes. The question is, when does protection become opacity that prevents you from operating effectively? Now the flip side, when hiding creates real operational problems. Troubleshooting blind spots. When performance degrades or failures occur, you can't inspect the hidden layers to diagnose root causes. You're reporting symptoms to support and waiting for them to investigate systems you can't see. During critical incidents, this helplessness is excruciating. Optimization limitations. You can't optimize what you can't measure or understand. If the provider hides performance characteristics, you can't make informed decisions about architecture. If they hide resource sharing details, you can't avoid noisy neighbor problems. Your optimization is limited to the abstraction layer you can see. Trust requirements. Hiding requires trust. You're trusting the provider's implementation is secure, reliable, and performs as advertised without being able to verify. For some organizations with strict security or compliance requirements, this level of trust isn't acceptable. They need transparency that hiding prevents. Vendor lock-in through opacity. When implementation details are hidden, migrating to other providers becomes harder. You don't know exactly how the current provider implements features, so replicating functionality elsewhere is difficult. Hiding strengthens lock-in, whether that's intentional or not. Incomplete understanding of dependencies. Hidden dependencies mean you don't know what could break your systems. Two services you use might share hidden infrastructure. An outage in one unexpectedly affects the other, and you didn't know they were connected because that connection was hidden. Inability to validate claims. Providers claim certain security controls, performance characteristics, or reliability features. With hiding, you can't independently verify those claims. You're relying on compliance certifications and trust, not direct evidence. Surprises during edge cases. Normal operation works fine within the abstraction. Edge cases reveal hidden implementation details you didn't know existed. Suddenly, behavior doesn't match your mental model because your model was based on the abstraction, not the hidden reality. Abstraction hiding is how cloud providers simplify complex infrastructure into consumable services. They hide implementation details deliberately, for security, for operational flexibility, for competitive advantage, and to protect you from overwhelming complexity. The hiding brings real benefits: faster development, simpler operations, cognitive load reduction. But it also creates problems: limited visibility, troubleshooting blind spots, trust requirements, and surprises when hidden reality doesn't match abstracted interface. Understanding what's being hidden from you is essential for making informed decisions about when cloud services meet your needs and when the opacity is too much. And remember, every simple interface is hiding something complex. The question is whether you're comfortable not knowing what. See you next time.